So my name is Subbu Allamaraju. I'm a Vice President of Technology at Expedia. I run, I help Expedia migrate from our data centers to the public cloud. I've been at Expedia for the last 2 years. Before that, I spent 5 years focusing on data center automation, building private clouds and platforms and whatnot. So I spent time on both the dark ages and so the future on the cloud side. So today, I want to talk to you about how to sell serverless to your colleagues. At Expedia, we are using serverless for about 2+ years. We at a last serverless conference in New York, one of my colleagues did a talk that shows 4 or 5 architecture patterns we use. And when I last checked, we run over 6 billion invocations every month. It's a fun statistic, but not really that cool, because once you figure out a stateless pattern, have the right building blocks, the system runs on its own. At Expedia is a fairly large travel company. We operate in about 75 countries, with 650 million visits every month from customers. So we sell flights, cars, train tickets, hotels, and whatnot. And you have brands like Expedia.com, Orbitz, Travelocity, Agencia for corporate travel, and HomeAway for vacation dental. So these are all part of Expedia Group. And just to give you a point, illustrate the scale at which we operate, we have some really large-scale flights and hotel search engines. And the hotel search engine does about 1 billion requests a day. And we update the inventory about 2.3 billion times. It's a fairly fun place to work at. And the even more fun is I get to lead our migration from data center to the cloud. And why this topic? Because as I talk to my colleagues at work and even in local meetups and events, oftentimes we hear folks saying, yes, this is cool, this is fun, but it's not good for me. And I thought, okay, why is it that? Why do we people? That led me to think about some of the reasons, some of the understanding. And so I want to walk through that and show you the mental models I use to explain why this is a natural progression from where we are. Just to get you some context, this is what we hear about when we search for with serverless pros and cons. Things like the call patterns are more complex, which is an extreme version of microservices. Unknown security risks. It is still new. It is not suitable for something long running, like if you have a front page of your website or your e-commerce site that's taking millions of hits a day. Would you put that on serverless, or would you put that on something more traditional like virtual machines or containers? Lock-in is a concern. Expensive. A number of speakers talked about having to watch for cost. Observability is hard. I believe we have a talk later today on that. Slow on cold start. It came up again and again in many talks. There's no standard, no local storage. In fact, one person even said it's just a fad. It'll go away. And to understand why, I want to take a step back to where we were a number of years ago. So I drew up some of the key events that happened in the history of cloud computing, as I understand it. It doesn't include all of it. It does include things that I think matter. They are sort of changing the paradigm step by step. So we had VMware show up in 2001. I think that's the reference I could find on hypervisors. We have Zen hypervisor, KVM Hyper-V, all came in the next 5-6 years. EC2, which revolutionized compute as a service. The first time we actually have an API to provision compute. Then we have things like Google App Engine. Mesos is another interesting development in 2009. I think that was the first time the paper got talked about publicly, and there was a more follow-up a few years later. And then Docker came along in 2013, sort of, which spun a different debate. If we were in a conference 4 or 5 years ago, we would be talking about VMs versus containers. We no longer talk about it. Then we have Kubernetes come up in 2014, a different evolution on distributed computing primitives on containers. And then 2014, we have Lambda, the fall of 2014 in the reInvent conference. It's about 3+ years. It's fairly young in the entire cloud computing spectrum. Then Google and Azure followed later in 2016. So what is interesting as I was putting this chart together is that my hypothesis, I don't have numbers to back it up, is that a lot of compute in the world is still operating on the lower left side, not here yet. And we have a long journey to go. In fact, my hypothesis is that out of all the compute that exists today, at least 50 to 70% is stateless. And the remaining is stateful or semi-stateful. But we haven't been building stateless applications with true stateless assumptions. That's going to change now. And if you search on Google, for example, on Kubernetes versus something, and you would hear about other cluster management platforms. But if you search on Google for serverless versus, you will find containers as the first result. It seems that we are often comparing these two paradigms, but I think it's a misguided approach in my view. And to understand that, I want to go back to the whys. Why is the transition happening the way it did over the last 17, 18 years? So very basic primitives for cloud. These haven't changed in the last 10 years at least. Even if you go to a conference in 2009, if you had gone to a conference in 2009, you probably saw something similar. Every enterprise operating on infrastructure needed these 4 things. One is velocity. You want your teams to deploy software when they're ready to deploy and not wait for weeks and months. Because traditionally, companies are used to doing bi-weekly, weekly releases. You have a war room set up, everybody important sits there, you deploy the code, the site is down for a while, and it comes back up. And that is still happening in some companies. The second is just-in-time allocation of all resources, whether it's compute, your load balancers, firewalls, and whatnot, storage as well. Now, this is interesting because traditionally, historically, I've worked in companies where if you are going to release a new version of a service 6 months down the line, one of the first things you do, you have the architecture diagrams. You walk into a capacity advisory board or capacity view board, and then they would approve or reject your request for capacity. And if it gets approved, the capacity shows up 3 months down the line, and it's sitting there for you to deploy. And oftentimes, you overestimate what you need. And this is the scenario that happens in companies, and nobody wants that. So we want just-in-time allocation. The third thing, we want robustness. When a machine goes down, we don't want to wake up. We want the system to heal itself. And we want infinite scalability. And this is important because every business has a set of traffic patterns. It could be daily patterns based on your location or type of business. It could be weekly, monthly, seasonal, whatnot. So you want your cost to follow your usage. So you want scalability to follow your usage, and you want near infinite scalability. You don't want to pre-provision. You just want to get what you need. So these are the 4 whys that are driving most of the changes happening in cloud. So how are we approaching these 4 whys before serverless, before containers, and before even VMs came along? Fairly simple. We were doing open loop automation. In fact, one of the earliest PaaS systems I worked on is very similar to that. We had an API, fortunately, to get provision bare metal. So you say, I need 10 machines. You click a button on or call an API. After 30 minutes, you get 10 machines. And then you write another automation to deploy your code on that. And your assumption is that your machines are not dying, so they remain as they are, and you keep deploying code on the same machines. This is the pattern that is universally is followed in many, many companies. It still exists today. So what is the outcome of that approach? You got velocity, so you're able to deploy faster and faster, but you did not get anything else out of it. You're still not robust. In fact, we used to write a script that checks for dead machines every night and files a ticket. The next day, someone looks at it and then replaces it with something else. So we didn't get robustness, we didn't get scalability because we are provisioning before. And over time, we figured out the need for closed loop automation. So in this model, this is actually how we evolved our own internal PaaS system. So instead of just open loop, we introduced some monitors to find when things fail, replace nodes, or add capacity. So this is how we started building the PaaS systems. We got velocity right with this model. If you are operating on the cloud, you also get just-in-time allocation. For example, I could put a cloud formation with auto-scaling groups to get a full closed-loop automation. You sort of get robustness out. Now, when a machine goes down, I can replace and not worry about a loss of capacity. I got some scalability. So this is good. In fact, PaaS systems, even in open source PaaS systems, used to look like this until fairly 3-4 years ago. This is all good for stateless compute. So we sort of figured out velocity and all robustness for stateless, but stateful hasn't changed for a long time. You walk into any enterprise, your stateful systems like databases, your messaging systems, queuing systems, all those services are human managed oftentimes because there is aversion to change, there is fear of losing data, the fear of taking down the business. So you typically put people to manage stateful systems. You don't upgrade whenever you want to upgrade. You have a specific upgrade cycle. You plan for the change. You don't do it randomly. So this is what was going on in the stateless world, stateful world. Then came along the next evolution. What if we create frameworks that rule them all? Because once we have sort of figured out the patterns for getting velocity, robustness, and scalability, we sort of create frameworks. This is the idea that Mesos popularized early on, that you have a framework that supports certain distributed systems primitives for some of these qualities, and you write apps to the framework. So this is good. In fact, Kubernetes takes this paradigm to a much greater extreme of creating a framework that can run everything in the world. It has all the right primitives for distributed systems. So you have the notion of pods and clusters and ways to write feedback loops. So you can pretty much write anything on top of it, which is good, one side, because you have a framework. Framework is opinionated. It actually forces you to do certain things right so that the system takes care of these qualities for you. The downside of that approach is, in my view, is that when you try to build something that rules them all, you create complicated systems. Now, this could be argued. You might disagree with me that, yes, no, it's actually nice to abstract all the primitives. But in reality, you don't want to have a system whose failure can take down all your applications at once. But that includes both stateful and stateless applications. Because stateful and stateless are different. They have different failure modes, different weight, different trade-offs. So this is probably not the best approach for writing applications. This is my realization. That comes to my next principle that I use a lot, which is to simplify and then automate. This is something that one of my colleagues taught me when we were doing automation data center. If you have, let's say, 10 steps to do something, you have some automated steps, some manual steps, some tickets, some approvals. And if you try to automate that, you end up creating a big workflow engine. It's automated, but still complicated. It still takes time because there are people involved. And the way you solve it is you first simplify the problem. You ask the whys, remove the variables, distill down into simpler processes and then automate. So this principle resonated well with me and in how I think about distributed systems. So I don't want to build a system that takes care of everything for me. I would rather build purpose-built systems and be able to make different trade-offs. What if I apply that thinking to the previous problem? So we have stateless and stateful, and we know that each of them require different trade-offs. On the stateless side, speed matters. I don't want to wait. I don't have to wait to deploy my code if it is stateless. And I can deal with ephemeral compute. I don't need durability. And the automation is simpler. For example, if a machine dies in a cluster, in a stateless cluster, I just replace with something else, an equivalent machine. I don't need to tell other nodes in the cluster about the change. Only the load balancer needs to know that. But if it is a stateful system, I have to use a different set of trade-offs. For example, if I have a MySQL server with a primary secondary, if I want to remove the primary and replace that node, I have to follow a different sequence of steps to replace that. So they require different trade-offs. On the stateful side, we go for durability, consistency, the rate of change is slower, which means that we can apply different trade-offs on each side. That lets me to think that we can make applications truly stateless. I want to emphasize the word truly because even though we have been building stateless systems all these years, we have made assumptions about state. For example, most application servers assume that they're going to live longer than their connection pool timeout. Because we know databases don't like too many connections, so we assume that there is a connection pool and that improves performance. Or we assume that I can cache some data in memory. Or I assume that there is an identity for the server, so I could go and patch it or push some configuration to the machine. So we make certain assumptions, but what if I remove those assumptions and make it truly stateless? And shift the stateful complexity out of my application. I don't want to have state in my application. It's truly ephemeral. And I can apply that thinking to rationalize how the world is moving in the cloud. One is, on the stateless side, we have a framework that gives me all the 4 whys. It makes me deploy code fast. I can get capacity when I need it and kill it off when I don't need it. I get robustness. I don't need to worry about failures anymore, at least failures at the infrastructure layer. And I get infinite scalability. What if we get all of these through a framework as a service? Again, the service word is important because if my framework is not running as a service, I have to worry about some of the robustness, allocation, and scalability concerns. So I need that framework to run as a service. On the other side, I can delegate my state to the cloud services. So this is fairly important for me because if you look at descriptions of cloud even 4 or 5 years ago, you have this notion of an IaaS layer, you have a PaaS layer, and maybe a SaaS layer. That kind of thinking, I think, is convoluted in today's standards because you got to think of how the managed services are evolving to make it easy to write stateless applications. That is the change that is going on in the industry. With that, I can conclude that a framework as a service is a natural way to abstract operational complexity. Because every other method we tried before didn't fully get to that point of giving me all the 4 whys. So this is the first time we are seeing, in fact, I would say this is the first time in the history of cloud we're actually seeing these 4 benefits materialize without much effort, without much operational effort. So a framework as a service is a natural way to abstract complexity, and a function is the simplest possible abstraction. This is how I explain why functions matter, why a stateless framework as a service like serverless matters, and why it makes no sense to compare it with something like containers or Kubernetes. They are totally different paradigms. In one paradigm, you're assuming that you have a framework that takes care of all distributed systems concepts and be able to run stateless and stateful applications. So technically, you could take IaaS primitives like bare metal or virtual machines and load balancers and whatnot, and run Kubernetes on top to get what you need. Whereas in this paradigm, you are using a function as a primitive to run on a framework, and the framework is abstracting all the work for you. So totally different paradigms. However, this paradigm does not work unless you embrace ecosystem. Put in even simpler words, serverless is useless unless you marry the ecosystem. If your colleagues or if your friends at work are not comfortable using, let's say, S3, Aurora, Dynamo, Kinesis, and whatnot, then they're probably not going to get much out of serverless at all. So because the paradigm is changing and they're sort of evolving together to make these systems, ecosystems evolving to make stateless easier to write. And the integration is getting much, much better every year. So you have to embrace the ecosystem to really take advantage of serverless. Now going back, what does this mean for all the naysayers? And there is a way to explain this. First is understanding the why. Now we talked about the why, the 4 whys, why we are doing what we're doing. And if I use that lens to explain some of these things, more complex patterns is a consequence of writing decentralized applications in smaller and smaller quantities so that I can release faster. So if I want to get higher velocity, I need to accept that more complex patterns is a consequence of what I'm doing. So it's something I asked for. It's not a limitation. It's a consequence of my choices. It's not suitable for long-running applications. Why would you want to run a long-running application? First of all, in a stateless paradigm. For example, if you have a job that takes more than 5 minutes, you may want to run it on a framework like Spark, perhaps, and not as a function. Because if a function dies in the middle, what do? Do you want to restart? How do you express idempotency? How do you express repeatability? So you have to pick the right problem for the right solution. And lock-in is another concern. You can also explain that. If frameworks are by nature opinionated, they lock you in. You pick Spring, you're locked into Spring. Unless, of course, you're talking about creating standards for all things on the cloud. Yes, you could create a standard for functions, sure, but then you want to go to standard for S3 or object storage, block storage, other primitives. You may have the next 20 years with standards for all these services, and the rest of the world has to stop. So lock-in is not a concern anymore. I think what's more important is that we are taking advantage of this ecosystem and create value for the customers. I don't want to be in the business of abstracting from cloud for the fear of lock-in. I would rather spend time creating value. So by understanding the why, I can sort of explain the kind of objections to serverless. Now, the second way to explain is that habits of today. This is what Simon called as inertia. Like things like unknown security risks or observability is hard. Observability is hard because the tools we have built for observability don't necessarily work in this model because you're running on a framework run as a service, so your tools for monitoring may not work the same way. So you have to think differently. So you have to think, sort of shed the habits of the past to take advantage of these things. Similarly, today is not tomorrow. Many people talked about cost. That it is expensive to run on serverless. Yes, it is perhaps, but I suspect that having been in this industry for the last 7, 8 years, economies of scale change costs. We have seen that in the early days of the compute. As compute usage increased, the costs came down over 3, 4 years. Now they are very close to each other. Same thing might happen, might not happen, I don't know, but today is not tomorrow. It might change. Same thing on slow on cold start. Yes, it is likely a concern today, but today is again not tomorrow. And I'm sure every company, all the cloud companies are working on that. I saw some great demos here that talk about serverless frameworks that are that don't have the cold start problem. Let's see what happens in the industry. And the last one someone said is, it's just a fad. I don't know how to respond to that. It is just I leave it to the trolls to explain why that is. So someone I know called Alessandro Pirelli, he works at Red Hat. He made this statement during reInvent last year. Imagine a new gen developer that starts his career learning and working on Lambda, nothing but Lambda. That experience will shape forever his worldview and expectations about how IT works. Everything we know and do today will be irrelevant. I think this is a very profound way of expressing what he observed. If a young college grad comes out of school and then he's trying to build something during the weekend, he's probably not going to learn how EC2 works. He's not going to probably install Kubernetes and learn to run it. He's probably going to start looking at something like Lambda, Alexa, and whatnot to build something interesting. So he's operating, or he or she, in fact, is operating at a much different level than we grew up with. So in some ways, we are ready for serverless, except that our habits and inertia are what may be preventing it. With that, thank you for the opportunity. And again, my Twitter handle, my blog is over there. And if you have time, you can take questions. If not, I can catch up afterwards.